Analysed.com.
Okay, students, today's our aim is to complete the previous year questions. We had one short series and we had a numerical session on each and every topic and theory analysis also. Okay, so whether this is the time where we have to cross check ourselves, is that our preparation is up to the mark or not. Okay, so to cross check ourselves, what was the previous year question and how you have to solve, is there any tricks for solving them? That is what we are going to complete in the today's session. Okay, so when you have the very short span of time and prepare to lot, then you can go through the one shot series of almost all chapters are already uploaded. Okay, then presently we are in the previous year questions. Some of the chapters are already uploaded, and slowly every chapter will be previous year questions also will be uploaded. Okay, so make use of that and try to be successful by smart study. Okay, let's start with the today's session. Now, here I will be giving one question, and you can pause the video or you can think, analyze yourself, then cross check with me explanatory answer. Okay, question number 1 is here. Now you can pause the video and you can start solving. Okay, now I think all of you have tried. Now let's see the explanation. Answer to this question is B. Okay, if you have already got it B, congratulations. And those who are not able to solve, don't worry. At the end of this session, we are going to have some, in between only, we are going to have some advanced level questions. Okay, it is a mix of the both mains, advanced and few NEET questions also. Okay, so here we have to use Q is equal to I into T formula. And here we are given with 10 milliampere. Okay, so 10 into 10 to the power of minus 3 milliampere current. Okay, time required we have to find out. And for hydrogen gas, H2, for revelation of hydrogen gas, 2H plus 2 electron gives hydrogen. Okay, so that means 1 mole of hydrogen require 2 into 96500. Okay, so accordingly when you substitute here, okay, so 0.01 mole, 0.01 mole will be 2 into 96500 into 0.01. That means obviously 2 into 965. This much current is required. So Q is equal to I into T, 10 to the power of minus 3 into 10 into T. On simplifying, you will get B option. Okay, this is the answer. Let's see the next question. Okay, next question is here. Start solving. Okay, now listen. Here I am explaining the answer. Formula we will be using normal Nernst equation only. The previous year when this exam came, when this question came in the exam, people found difficulty in finding out the N value and where to use Pyq'S. Okay, so very simple. N is equal to 4. How it is 4? See, each iron is changing from the oxidation number 0 to +2, like the 2 iron we have. Therefore, the N value will be 4. And from the pH, we can find out H plus concentration is equal to 10 to the power of minus 3. H plus concentration is equal to 10 to the power of minus 3. So this is to be substituted here, and partial pressure of O2. Partial pressure of O2 is to be substituted here. Fe plus 2. Fe plus 2 concentration is required here. Okay. So on substituting, E naught cell is equal to 1.67, 0.0591 divided by 4 into log Fe2 plus is 10 to the power of minus 3 whole square. Whole divided by partial pressure of O2 is 10 to the power of minus 1 into H plus concentration is 10 to the power of minus 3 to the power of 4. On simplifying, we will get D option. We will get D option. Okay. So note down this. Okay, next question is updated. Now you can start solving. I will tell you the what problem, what mistakes actually that time exam people faced. That will be very helpful to you. You won't find in the books or you won't understand while you solve on your own. Okay, it is just a theory question, but based on this, lot of arrangement questions are coming nowadays. Therefore, logic I will tell you, MnO4 reduction potential. This is reduction potential is higher. Okay, so you can make it as a rule. Reduction potential higher, oxidizing power will be higher. Okay, higher the reduction potential, then oxidizing power will be higher. So answer will be D option. Okay, answer will be D option. This is the trick, or you can say logic. Okay, reduction potential higher, then oxidizing power will be higher. Okay, here is the advanced level question, but it is of 2014, so it may be reflected in the mains or it can be reflected for NEET also. Okay. In the galvanic cell theory based question, so you should be conceptually strong to answer this question. Okay, so actually here it is a multi-correct option. If it is a multi-correct option, it will be A and C, but you have to select only one answer. Most appropriate will be only A. Okay, see, actually it is necessary for occurrence of the cell reaction, but if you don't use also, reaction will occur, but for some time. Okay, so it is not most appropriate. Most appropriate will be A option. Okay, so diffusion is not stopped and does not ensure the mixing. So this will occur in fuse peaking. Okay, this was a contradiction in the 2014. It was single correct option. So then this was the explanation given that time. Okay, so single correct option A, and both correct answer will be A and C. Okay. Okay, next question is updated here. 2 farad of electricity passed through the solution of copper sulfate, mass of copper deposited. It is very, very simple question, but tricky question. Answer very carefully. Okay, answer is very simple. It is B option. Understood? See, Cu2 plus 2 electrons gives Cu. Okay, so that means 2 Faraday will give you 1 mole. 1 mole mass is 63.5. Now let's see the next question. Next question, for the following electrochemical cell, PET oblique H2 1 bar H plus M4 plus oblique M2. This is called as a redox electrode. M4 plus comma M2. It is a redox electrode, and E naught cell you have to find out. Already given, but X value you have to find out. Okay, here is the solution. Here we already this total value is given. Okay, M2 plus oblique M4 plus. So in this place, M2 plus oblique M4 plus, we can write as a 10 to the power of X. H plus concentration. H plus concentration is given as 1 molarity. Partial pressure of hydrogen is given as 1 bar. Okay. So on substituting and simplifying, you will get X is equal to 2. Therefore, D option is correct. Now let's see the next question. Okay, so this question appeared to be already discussed, but it is not discussed. There is a twist in the question. Okay, here in the earlier we have studied the strongest oxidizing agent, and you are given with reduction potential. Okay, Logic can be applied, but here opposite logic. Okay, so reduction potential lowest, then reducing property, reducing power will be highest. Okay, so this is the trick to solve this type of question. So answer will be chromium. Chromium got the least reduction potential. Okay. Okay, here the options are there, chromium and chromium plus 3. Here about the reducing agent. So the substance which undergoes oxidation will act as a reducing agent. So chromium will undergo oxidation, therefore it is reducing agent. So answer is B. Okay, next question. How long approximate should be electrolyzed by passing through 100 ampere so that oxygen released completely burn 27 points? Stoichiometry is related here. So very good question. So try to solve it without balancing. If you are doing, you will get wrong answer among this. Okay, here first of all, what you have to do is apply the stoichiometry. Apply the stoichiometry after the balancing the equation. B2H6 on burning will give you the boric anhydride, that is B2O3. So after balancing 3 moles, here it is given 10.8. Don't take your atomic mass approximately. So when you use it, then you will get 27.66. That means 1 mole. So 1 mole of B2H6 requires 3 mole of hydrogen. Okay. And people are doing wrong here. See here, 2O2 minus. Therefore, it will be 4 electrons. 4 electron will give you the 1 mole of O2. Okay. So that means 4 into 96500 will give you 1 mole. But we require 3 mole. Okay. So 3 mole will be 3 into 4 into 96500. This is the charge required. Then what you will do? Q is equal to I into T. So Q you will substitute here and answer is in hours. So this time will be in seconds. Okay, I you will find out. I already given, I think 100 amperes. So after converting the seconds into hours, then only you will get the correct answer. Okay, answer to this question is B option, 3.2 hours. Answer is 3.2 hours. Okay, next question. That two logics I told you to find out the reducing agent and oxidizing power. That logic is so many times the questions are there. So try to apply it here, then you tell me. You can send the message. Okay, if you apply the logic, C is the answer. It has the highest positive reduction potential. Highest positive reduction potential. Okay, next question. Calculate the standard cell potential of the cell which of the following reaction takes place. Very important. Try to solve it very carefully. Okay, now listen carefully. Here, this is a combination of Latimer diagram and cell potential. Okay, so try to understand. Okay, next question is if the standard electrode potential of cell is 2 volt at 300 Kelvin. Okay, so 290 at also no problem because it is not a integer question. That means 0.059 we can take, I mean to say. Equilibrium constant for the reaction you have to find out. Okay, these questions people are able to solve the question, but they are having trouble in the time consumption. Okay, so this direct formula will be useful. See, already we know from the thermodynamics delta G naught is equal to minus RT ln K. And from electrochemistry, we know that delta G is equal to minus E naught cell. But here question is about K and given with the E naught cell. So by relating them, we can directly get ln K is equal to NF E naught cell. Okay. Here N will be 2 because zinc and copper are exchanging 2 electron 96500 and E naught cell is given as a 2. R value you will take it as a 8 because already given here. So don't worry. Given value only will substitute. Okay, and temperature is 300 Kelvin. So on simplifying, in terms of the E, you will get 160. E to the power of 160. So A is the option. Okay, next question, let us see. Okay, here is the detailed solution. First of all, you have to identify anode and cathode. H2 gives 2H plus 2 electron, and this is the problem. This is a sparingly soluble salt. AgCl, only silver is reducing from +1 to 0. There is no change in the oxidation number of the chlorine, but here we have got the 2 electron. If it is concentration is 1, no problem. E naught cell will not change, but here there will be changes if you don't consider that square. Okay, so all values are given. Then if you substitute, then you will get the 0.2 volt as the answer. 0.2. That is A option is correct. Okay, note down A option. Now next theory question. Electrolytes usually use the electroplating of. It is simply AuCl. Okay, you will find this type of PYQ in the coordination compound also, in metallurgy also you will find. So I think you understood now. Let's go to the next question. Okay, see here the biggest question, try time consuming question, but you don't worry, already printed, so it will not be time consuming for writing on the board. Question appear to be very lengthy, very problematic, but if you understand clearly, we want to get, our aim is to get the maximum reduction potential. See, we can understand zinc reduction potential is more negative. So we have to select a cathode whose reduction potential highest and positive. So what is the highest and positive? Oh, sorry, it is a mistake, I think. Both are AU. Actually, it will be AG. Okay, B option will be AG. So highest positive must be there. So answer will be gold. Okay, AU 3 plus. Okay, is that clear? Now let's go for the next question. Okay, now listen carefully. Here the given equilibrium constant, that means indirectly it is equilibrium. At equilibrium, E cell will be 0. In the concentration cell, E naught cell will be 0. So if I substitute here 0, E naught cell is equal to 0.059 upon N upon log Q. Actually, log Q will be Kc. Okay. So Kc is given as 10 into 10 to the power of 15. So you have to be very careful. 10 to the power of 16 it is. And 2 electrons are transferred. So 2. So E naught cell you will get 0.0. See here, values also same. See how much near values. So millivolt or volt. That should be very careful. Answer is B option. Okay, this question is based upon the conductomeric titration. Conductomeric titration. A. This is a C. Weak salt of the weak base and weak acid. Okay. So then conductivity increases, then does not change much because it is going to form a buffer solution. Okay. Next, B. B will be conductivity does not change much initially because replacement of potassium by the silver. Okay. Then increases. When you still add the AgNO3, NO3 minus will cause an increase. Okay. Next, acetic acid and KOH. Acetic acid and KOH, the conductivity first decreases because we are replacing the weak acid. Okay. Then increase does not change much again because buffer formation will be there. First of all, it will be salt. Okay. Then it will be buffer. Okay. C answer will be 2. Then D answer will be left over only 1. So 1. So now check A3, B. So fourth option is correct, I think. Fourth option. Okay, B4, C2. Okay. Okay, now we are with the some lengthy integer type questions. So take less time and answer with accuracy. Okay, this was the paragraph. Based upon this questions I am going to give you. I think all of you studied the paragraph. Now let's see the question. Here the three questions are there related to that. Try to solve them. Okay, here check here 4 molar solution is given. So in the 4 molar solution and 500 ml, that means NaCl will be 2 moles. Per 1 liter, 4 moles. Per 500, 2 moles. Okay, this is going to be used in the question. So that's why I have again put this question back. Okay, next slide, let us see. Okay, see here, and 2 moles of NaCl will give 2 Na plus Cl2. Okay, so we have 2 moles of Cl, but the question is about the chlorine gas award. So 2 moles of chlorine atoms, 2 moles of chlorine atom will be only 1 mole of chlorine gas. Okay, chlorine gas is very important. So answer B. Same way, if the cathode is mercury electrode, maximum weight of amalgam form. Maximum weight of amalgam form. Okay. Okay, here maximum weight of amalgam formed will be already we have seen 2 moles of Cl and 2 moles of sodium. So 2 into 23, that is 46. 46 must be increased. So 446. Okay, here most of the people what they have done. So 2 Faraday for sodium, 2 Faraday for chlorine. No, it is not like that. 2 Faraday only you have to take 2 into 96500. Okay, so answer will be D option. So this misconcept should not be there. Both combinedly 2 Faraday. Here next paragraph and questions are together. So try to read and solve carefully. Okay, here in this question, find out E naught. If E naught cell is positive, E naught cell is positive, then delta G will be negative because delta G is equal to minus NF E naught cell. So already you are given with E naught cell. Okay, and you have to be very careful. See here, MB. Okay, and if a cell is spontaneous, that means it will be positive. So delta G will be negative. So according to that, if you say 26th question, answer will be B. Okay, E cell is positive, delta G will be negative. Now only one change here. 0.05 molar is replaced with 0.0025. So there won't be change in the millivolt. Okay, it will remain as a millivolt and directly you can do it. See, concentration is reduced to half. Understood? Then voltage will become double. Okay. How much it will be? Earlier it was this question. If you calculate already 70, so it will be 140 millivolt. Need not to do anything. Okay. Next one is the integer type question. 2015 advanced paper 2. So here we are given with the two weak acid HX and HY. So HX let us take Ka1 and HY will let us take as a Ka2. So as per the Oswald dilution law, these formulas are written. And lambda m of Hx is equal to, let us take lambda m1 and Hy as a m2. Here it is given 10 times smaller than, okay, molar conductivity of Hy. So this relation we can write delta m1 by is equal to delta m2 by 10. And K is equal to C alpha square. For the time being, I am neglecting as a 1 minus alpha. Okay. So then Ka1 by Ka2 is equal to C1 by C2 into square root of this is here square is there. So alpha will be square root of Ka by C. Okay. So after substituting and applying the logarithm Pka, apply log on both sides, then you will get P. Answer will be 3. The conductance of 0.0015 molar aqueous solution of a weak monobasic acid was determined by using conductivity of platinized platinum electrode. Okay. Okay, here is the detailed solution. Listen carefully. Conductivity is equal to G into conductance into cell constant. Okay. So 5 into 10 to the power of minus 7, 5 into 10 to the power of minus 7, and 120 centimeter area, and cross section is 1 centimeter square. So we got the conductivity. Now molar conductivity is equal to conductivity upon concentration. So conductivity we got it here. Concentration is here 0.0015. So we got it 40. Okay. Sorry, 4. So here 40 centimeter square. Everywhere see here centimeter inverse only we want answer. Here also centimeter. Here also centimeter. Siemens. Okay. And pH of solution is given as a 4. So by using pH and by using lambda, we can find out alpha value. And again substituting back in the molar conductivity, 6 into 10 to the power of 2. So in place of the Z, we got Z is equal to 6. Next question, electrochemical cell with magnesium oblique magnesium 2 plus copper 2 positive oblique copper is 2.7. When concentration is changed to X molarity, then pH potential changed to 2.67. Concentration changed, pH changed. We have to find out what is the present concentration. Okay, here reaction taking place. Magnesium is undergoing oxidation, copper is undergoing reduction. So E cell is equal. Standard potential already given as 2.7, and E cell is given as 2.67. Okay. So remaining values you can substitute, and you have to be very careful here. F by R is equal to, you have to take 11,500. Remaining temperature 300 Kelvin. Okay. So after substituting it, log 10 is equal to 2.30. Okay. ln 10, sorry. So after substituting and simplifying, X you will get 10. Okay, next question. Read carefully. Oxidation number, entropy, enthalpy, all are combined together in this question. So thermodynamics also to be strong. Okay, here is the solution. First of all, you have to make the balanced equation. 2a plus b n plus gives 2a n plus b. So already it is given delta H naught is equal to 2 into delta Hg, and EMF of cell is 0. EMF of cell is 0. And by using the Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S. So by substituting these two values, you will get delta S is equal to simply delta G upon T. So delta G according to electrochemistry minus nRT log K. Okay. So after simplifying, you will get minus 11.6. I hope all of you enjoyed the session with the short tricks and direct concept making. I wish you success in your examinations.